Good afternoon, everybody. My name is Conrad Fernandes, and I know you were very excited right at the beginning of the day when Mr. Bearden and folks talked about the World Cup and the billion tweets, from the World Cup. But the unfortunate part is the U.S. is not, part of it. Well, I have to say I'm from the Washington, D.C. area, and I don't know who's, probably not a lot of folks from D.C. area, but for those of us who are from there, I've got to wear my cap. The Washington Capitals won the Stanley Cup, and so props to Washington D.C. for the first win ever in franchise history for 44 years. So that almost felt like my vote today was for Iceland winning for exactly that same reason, so that they may sort of enjoy that same first time, a success. Since there's no hockey to watch, I'm very happy now to be here speaking to you folks about Hadoop security and specifically monitoring, security audit, logging, and monitoring, which falls under governance. But as we will see, moving along, it's really in the realm of auditing and governance and higher level security. Just quick background. So my name is Conrad Fernandes. I represent Johns Hopkins APL. But before that, I was with Booz Allen Hamilton and a bunch of companies where we're really helping the DoD and federal government for security for the last 20 years. And this was before big data. This was before AWS security, so cloud security. So those are the areas of my interest. I also talk at places like reInvent, since we also do a lot of, at APL, we also do a lot of cloud security too, in addition to Hadoop. So beyond that, beyond APL, one of our joint projects with Hopkins. So just quickly, so Johns Hopkins APL, so that's the logo on the left side. That's a university-affiliated research center. Like I said, we deal a lot with DoD, a lot with space, a lot with those type of sponsors. Whereas Hopkins Medical has asked APL to be jointly, working on a solution for their precision medicine initiative. And for those who aren't familiar with that, it's really very cutting-edge technology in the medical world that, as you can see from that graphic in the middle, it very precisely targets you if you have either prostate cancer or multiple sclerosis or one of several precision medicine areas where they do longitudinal studies. And again, they target you for very specific delivery. So it's a fantastic initiative, and you can do a lot of online research about the advancements they're making in that particular area. And it affects everybody we know, to be honest, who's been affected by cancer and whatnot. So on the right side is the technical aspect, and that is it's built on a big data platform. And as you can see, the two logos, prominent logos, HDF, which is essentially ePHI, and Dataflow, which is data in motion, and on the far right is HDP, which is the platform we know and love, which is really data at rest, Hive, HBase, all that good stuff, right? So that is the premise, that's the backstage of everything else I'm going to talk about in terms of auditing and logging. So before that, right up front, what's the concern, right? I'm not here to really tell you our architecture, because you've probably seen a lot of that today. Right? So what's the concern? This should look familiar to a lot of you. Since this particular project is really primarily based with patient records, HIPAA compliance is clearly one of the biggest mandates, for electronic protected health information, so ePHI. But for those of you who are in the DoD space or federal space, there's FISMA compliance, there's DFARS, for those of you who are DoD contractors like APL is. Northrop Grumman gave a talk today, same thing. They're all in the same boat. All of us have to essentially adhere to these security compliance practices. So, whoops, did I hit the wrong button? Sorry. Right, so compliance, here's the ultimate question. Is compliance good enough? How many of you have heard of Anthem, the health insurance? Yeah, I figured a lot of you would. So I'm not sure if you're familiar with the most recent announcement of $115 million fine, right? Pretty significant. Does anyone remember when the hack actually happened? Because this announcement was last year, 2017. Anybody?
Was it 9 months before?
Yeah, no, much longer than that. It was in 2015. But if you read the report, I'm not going to get into it, was that the perpetrators, the adversary, was in there at least exactly 9 months before the breach was discovered. And so that's going to be significant because the rest of this talk is really predicated on visibility that I'm going to get into. And that is, and it's also the premise that this is an old graphic that many of us used from 20 years ago. I don't know if it's still around on the interwebs, but this is something we've always said, and that is compliance is not equal to security. I see a lot of head nodding. And while compliance, by the way, this is the only build out I have, so please bear with this. So while compliance is a good start, aiming for enhanced visibility is should really be your goal. And I'll explain this, and I'm going to leave you with some very, very practical examples for how to implement this in your space. So just another recap. The challenges of being secure are that we definitely are in a very, very complex, hybrid big data environment today. So we got Hadoop clusters, and I'm going to focus on that. But there's also Docker containers. I'm not going to focus on that. That's subject of a follow-up discussion if anyone's interested, and other client platforms. And there are also multiple entries into the environment. So the biggest question on the table is, do you, and this is something for you to think about, do you have adequate visibility? How many of you can actually nod and say you have adequate visibility if you truly are aware of your security, visibility? Okay, I don't see a lot, but, and that's fine, because none of us really do. So, going back to the platform itself, right, having asked those questions, here's just a high-level cheat sheet of what the precision medicine platform looks like. A number of different patient databases where data is ingested from. So you see Epic, Red Seal. These are just well known if you're in the medical world. The point of this is that there are data sources on the left. There's the discovery and analysis platform in the middle, which is pretty much, as you can see, ePHI ingests that, and you have both columnar databases like HBase, and you also have Hive. And on top of that, you have the research environment that the researchers and the doctors are working on, and they include Jupyter notebooks, they include containers, they include MySQL, and so on and so forth. And that's delivered to the end consumer of this, which is pretty much, again, a doctor or researcher. So when you strip away all that fancy stuff and the doodads that were from the previous slide, here's just a skeleton of what's left, because this is what, if you're a security monitor, this is what you really care about that you're going to have to tap, which we will see in a few moments. And so here's a pattern that should look familiar, and that is on the left. I've just boiled it down to a couple of well-known ingest components, which is ePHI and Scoop. And the beating heart in the middle is the Hadoop cluster. And you'll notice that there's slightly different shades of green. Whether, so you have the data, your file system, HDFS, and you have the databases like HBase and Hive. But I'm going to focus on the 3 dark green ones, which is Knox, Atlas, and Ranger. And you should also notice, very purposefully, I didn't actually connect all these things together because, as you can see, it is a connected system in the middle, right? All the stuff in the middle is well connected, but all the stuff you see on the right-hand side, right? Docker, there's scientists with Jupyter Hub and so on, and JDBC client to attach to it through other software goes through primarily, we're trying to use Knox for that. So just picture this, because the rest of everything else is going to be the visibility on these things. And here's just a quick cheat sheet. It says you should have a dashboard that has a single pane of glass. It's always a good idea. In fact, it's more than a good idea to centralize your log collection and have forwarding agents. And and actionable intelligence, on the data that you collected. So this is what it looks like in sort of a cheat sheet. So I removed all the words, in the pattern that I described earlier, right? The flow, the Hadoop cluster in the middle, and all the clients that interact with the cluster. Because at the end of the day, now we happen to use Splunk. Both APL uses Splunk, as well as Johns Hopkins Medicine uses Splunk. The enterprises use Splunk. You don't have to. I'm only giving the example with Splunk, but you can replace it with whatever, SumoLogic, Loggly. There's a whole bunch. I'm not here to promote Splunk. They're not paying me for this talk. So, but we happen to use that, and that's what a dashboard would look like. So, how do you do it, right? So the big question is, how are you going to automate this? How are you going to install this on all your nodes? I've heard today of some people talk about a 150 node cluster. We don't have that many nodes. But so one of the key things we are trying to do that, in fact, I've helped implement is automation, and that is how you configure all your agents on the boxes using an Ansible playbook. And to share that with you, I actually have a working script that's showing right now, and it's almost Ansible to me is almost self-explanatory, right? So what this script does is so this is a YAML format, which is what Ansible happens to be in. And long story short, I'm just going to focus on like the tasks, which is it copies the files that need to be installed on the host, and then it calls this a bunch of handlers, which is start Splunk the first time. Actually, this pointer is not quite working. Stop Splunk, copy the deployment server, and restart Splunk, which is continued on the next page. Right? And so I'm sharing this with you folks so you can read this later. But the point of this is that the key is on the right-hand side, which is your host file. If you spin up a new cluster, all you have to do is add the names to this. And since Ansible is idempotent, you can just keep adding hosts. It's not like it's going to reinstall on all the ones that have it. It checks, and if it's already there, it's not going to reinstall it. And so then you just run the playbook with that script, literally that script that says Ansible playbook, install Splunk forwarder, and lo and behold, voila, you'll get it. So hopefully that's exciting for those folks who, well, like me, didn't have anything to start off with and use something like this that just works. So moving along, in the interest of time, to the actual interpretation now, right? So let's pretend, hey, we got all those agents and all those boxes. We're getting telemetry to the Splunk Enterprise, search heads, right? That's going to the top. So what do these look like? So I'm going to go through again, I'm only going to focus on the three main parts of your authentication and authorization. So Knox is authentication. It's your entry point. It's a reverse proxy into all the services that all the stuff you saw on the right-hand side try to talk to inside the cluster, including Hive, HBase, and so on. The other thing we have done, by the way, is implement a single sign-on. We happen to use Shibboleth and SiteMinder as identity provider. You can use, there's tons of examples. I think that, I wouldn't say tons, actually. I take that back. The Hadoop document, HTTP document has other examples. But we happen to do it with Shibboleth and got it to work. That's what a log file looks like. On the right-hand side, it's very hard to really interpret, but I just give you an example of an actual ones. I did fake out the IP number so that it's, we don't disclose any PII data, but that's pretty much what it looks like. And when you run a curl command, so for those who are not familiar, the beauty of Knox is that it hides all the all the ports. So all you do is you say, I want to run a web, in this case, web HDFS, or for beeline, you just run a beeline command using a connection string. In this case, it's listing the directory, right? That's what the list status is, and you're good to go. The gateway will track all that. So the question is, how is this interpreted inside your search heads? Now, whether you're using Splunk or SumoLogic, you can. So I've written an extraction expression. Does it look right to you guys? I mean, that's a joke, right? It's a little hard to read, but trust me, it works because as you can see in the bottom half, That's what that extraction will look like if you enter that in Splunk. So you can literally take this, copy paste this into, if you have Splunk or Sumo, what have you, right? Because it's a regular expression search. And so that's just a regex over the previous slide. So just really quickly going back. So that parses out all these fields out here that you see here, and you end up with these columns. So the key thing is you see things like logger name, your target service. In this case, it's Hive. So I pipe it very specifically to a search like Hive, and put it in a table format for those particular groups. For those who aren't familiar with regex, you extract the groups, and then next thing you know, you have a very nice table, and you can sort by any field. So that's the premise of something like this. And like I said, you're free to use it. Knock yourselves out with this. I just show another example with Web HDFS. The previous one was Hive. Here's Web HDFS. And of course, I had to scrub a lot of the data. But you can see that, for example, you can have attribution to the user, which I had to also scrub. But you can see that its ingest pipelines is where this particular Web HDFS is landing those calls. And so again, accounting and auditing is all about accountability. So you can use all that in your search heads, in your search engine to normalize the data. One more example with Knox SSO. The reason I put this is somebody did ask me for, very specifically for SSO. Since we've implemented SSO, you can catch all that really quickly. So since this is sorted by date and timestamps, the way to read any stack is bottom up. So you can see that there's an authentication action that's here. And for those of you who can't read, anyway, you can see a URL there, and the status code is 303. Anybody here know what 303 is? Or web experts? HTTP? Yeah, redirect. So you can see a redirect to the actual service, which is, with the actual service, and then you can see the authentication and the success. So you can do the whole trail. This is how you can do investigations and so on and so forth. Again, you can have the slides, and you can study this later. It's a good study, by the way, if I do say so myself. So moving on from Knox is Atlas. This is a little bit simpler. As you can see, it's a simpler regex I had to write because it's a simpler string to parse out. And the fields are, again, user. You get the source IP. You get the request. So you can see here a bunch of get requests or post. And you can see things like this particular user is going in, is annotating bulk classifications. The lineage is in here. And there's a whole bunch of interesting information, that you should understand what's your norm, in the environment if you're a security person. And finally, I want to get to Ranger. Ranger is where all the juicy stuff is. So for those of you who have heard Ranger, but not clear on what it is, it's really an authorization. It's one of the key pieces in the puzzle, in the security puzzle, because it does authorization. And it does it for pretty much the rest of the stack inside the cluster, right? So you can see the litany list of Hive, HBSS, the Storm, Yarn, and I'll show you a few examples of those. So you can catch all that, on your system. But the other thing I want to point out, and this is an important bullet, is one of the ways we made this available is through NFS. So the problem with Ranger is it has its own database, right? So any administrator out here who set up Ranger, whether it's Postgres or MySQL, it's in a database. So what we have done is we have it available, and I put a simple diagram to show you that the NFS gateway makes all the Ranger audits available through a local file system. And this is literally just an LS, and of course I had to scrub the rest of the identifying information. But the point is that there's a mount point that makes the Ranger logs available for you to then consume through your Splunk agent into your Splunk enterprise, right? So here's an example of what one looks like. And the other nice thing about, because Ranger audits go out to HDFS, and that HDFS is made available through the local file system, they also do one more thing, and that is now, I don't have to write a parser for this. So the sources, your source will vary. For us, it's that particular path. right? NFS, audit logs, Ranger, audit, Atlas in this case. But the nice thing is that now it's JSON key value pairs. So it's very nice. You can literally search for just the actions. Like in this case, it's create, right? So this particular example, the user, which is I had to scrub, is creating some metadata in Atlas. It doesn't matter what it is in this case, because again, like I said, I had to scrub it. But as an investigator or security personnel that's monitoring what's the norm, right? And by the way, sometimes a user is a service. We also have services, and it's not just a human user. But the point is you can capture all that in these key value pairs. And by the way, the schema is well defined on the Apache Atlas, Ranger schema. And so the next plugin is Hive, which a lot of people, if not everybody, uses Hive. So here also you can hunt for any CRUD activity, create, update, delete, and so on. And the other point to note here is that the enforcer is a Ranger ACL. And I'll come to it's either Ranger ACL or Hadoop HCL. But for the most part, they're Ranger ACLs because those are your policies that you write in Ranger, right, for accesses to various resources. Moving on to Yarn. So Yarn, is a resource manager, and it submits a lot of jobs on behalf of other applications, right? Right. So when other applications call for a job, Yarn helps schedule that. So in this case, can you read? You can actually see who requests, what's the request data and the action. I don't know how clear this is, but can you see the request data here is in this case is an Oozie action? Yeah. So there's a lot of intel. There's a lot of intel you can get from all of this. Once you make, again, these particular logs available, like I said, in this case, to an NFS mount point. So it's really, really useful. And you can see the action is submit app. So you can do all sorts of statistics on how many creates, how many submit apps, who's doing it, and start developing some norms on the various activities in your cluster. I don't know if this is the last example. No, after this is one more. So HBase, just to keep all the columnar people happy, since everybody only talks about Hive and not HBase. But here, too, you can see that the resource type is a table. The repo is like an HBase, and it's an Ranger ACL, and again, another create action. So you're going to see a lot of that. But also watch for the deletes, right? I mean, got to know who's deleting stuff, who's updating it, so that you have full accountability. Kafka. Yeah, I guess I threw in Kafka too. So you can see anything and everything related to the Ranger policies for all the different plugins. So this is really nice. It's a one-stop shop for all. This is the last one I thought of sharing because here's an example where the enforcer is Hadoop ACL. So, and the other thing I also noticed, and I think it's a direct correlation, and that's policy is always going to be -1. If you go back and look at these slides, once they're published, you'll see that there's a policy number for every policy that's written. That's Ranger ACL. But for an Hadoop ACL, it's -1. So it's just another way you can look for policies that are writing to disk. In this case, who is the requested user? Can you see it's not a person? Who is it? Yeah, it's ePHI, exactly. So in this case, and you can see almost similar to the other, remember the different perspectives, right? This is the Ranger decision. This is the Ranger policy decision making that allowed this particular thing. Whereas with the Knox example also had a ingest pipeline. You can see the resource path is ingest pipeline. But that was because Knox can allow you in, but it does not authorize, right? Knox is strictly authentication for the user. This is the user not only authenticated in the system, but this is what the user or service, right? A service account, right? Not trying to distinguish. It doesn't matter who it is. You have to know what the norm is in your organization. But the point is now you have full accountability into all this. You see that as an ingest pipeline, and and you can take it from there, right? So putting it all together. Not only should you have the ones I've talked about, so I've actually focused on the ones in the middle. Obviously, didn't have time to talk about Docker. I do a separate talk for just Docker because Docker is a different animal for injecting a Splunk agent into a Docker container. But the point is, trap your containers, trap ePHI, VPN, so we have a very secure boundary. So we sometimes correlate all our logs for those who enter the precision medicine space, because only certain users can get into that particular space. It's only one part of the entire medical school of medicine. And of course, your firewall logs. So if you want a true security picture and a true accountability, right? So I would argue that in the case of Anthem, here's the thing, right? They were compliant, and we can move on to the key takeaways, right? I would contend that they were compliant, but they didn't have that level of visibility, right? I mean, any billion-dollar corporation is going to have, they're going to be compliant, right? So it's a great thing to start off with. There's no doubt about it. Well, in many cases you're required to, right? Collect logs, but if you don't know what those logs are, and believe me, there's a billion events sometimes, that you have to parse out and filter out. Without the proper visibility, that's where you get into your black belt, type of advanced foo of security monitoring and logging. You're just not going to know what's going on in your system. So that's what actually helps you avoid breaches. It's this part here, and it's a level of maturity that will take time. None of us have a start off here. When I started, we were pretty much up there and started gravitating towards more advanced analysis, which is again a subject of a different discussion of how you do the analysis. But at least this should start you on that journey. And how you do it is on this slide, and that is, centrally collect all your logs, as we said. That's those disks out there, those indexers that in the case of Splunk has it, and I'm sure the other ones do too, like SumoLogic and all. Just trying to spread the love across, right? It doesn't matter which SIEM you pick, just pick one, that does good correlation, and then automate the telemetry. Just automate the installation. And I shared an example of at least using Ansible with you that you could literally take home and use. And once you do all that and you're collecting telemetry, the takeaways are, extract and normalize. So I give you tons of examples of those regexes that you can use to extract into groups in those fields, and then normalize your data so that then you can start correlating times, you can start correlating users, right, and their activities, and you can draw timelines, and it's really, classic investigation, and analysis stuff. But especially don't forget these three big ones. I actually liked it when, who was it, today's keynote, I believe it was Brian Hopkins, I think no relation to Johns Hopkins, but from Forrester, when he called it Hadoop and friends. Well, yeah, these are the friends, right? So these are your best friends if you're a security person. So I liked his terminology this morning. That's what I'm going to call it now. So Hadoop and the friends here. Again, Knox is for authentication. It's a reverse proxy, and you can use single sign-on. And single sign-on is great too, because single sign-on is strictly users. There are no services that are SSO. So that's another thing you can track. Atlas for your metadata and tagging. And in fact, Ranger uses that metadata, can use tags as policy decision making. So you have, and so that's what this particular takeaway is work on the details of what it is, making sense out of Splunk, your SIEM, and how you interpret the results from that once you've collected it, once you're analyzing it, once you have it centrally correlated. Finally, don't forget all the other interactions, right? Today we heard at today's keynote too, that there's going to be tons of interactions with in a distributed world. It's not, it's not going to be clean. Everybody's going to use Zeppelin, right? Everyone's going to use Hue inside the platform. There's going to be a ton of those blue, the blue squares on the far right, if you remember the architectural pattern. So collect all those, collect the VPN logs, collect the firewall logs, and correlate that. And so with that, yep. So on behalf of Johns Hopkins and Johns Hopkins APL and Johns Hopkins Medicine, thank you for your time. And so, do you have time for any questions? Okay. Oh, okay. So I left time for questions.
What you guys are using for keystroke recording for server level?
I'm sorry. What was that?
What you guys are using for keystroke recording for the server level? Like
Okay.
if somebody logging to the box, any of the Hadoop node.
Oh, that's a great question. So the question was, what are we using to, okay, yes, I did not. So, if I redid the slides, I would add, well, I guess in one of the previous slides where I showed you all the things we're capturing, we also capture PAM logs. So we also have PAM. So, pluggable authentication modules, classic from 20 years ago. So anybody that SSHs in, we collect those logs too. There's a bunch of logs I did not show in the interest of not trying to, show you everything in the kitchen sink. But that's a good question because that's part of the kitchen sink.
No, but PAM record who's logging what time, right?
Yeah.
If I type some commands, I run the RF against the /root.
Oh.
As a root, so how you guys are capturing those information?
Yeah, so that would be like capturing Windows events. So because these are Linux servers, yeah, I don't believe, I'll have to check with the enterprise team, with the Hopkins enterprise team, but I don't know if there's like a separate log collection for the equivalent of Linux events, right? Yeah, there's Linus. So there's a bunch of tools that are available where we could scrape that and have that. I think right now that's not. So that is another sort of secondary good question. In fact, it's a really good question because if in this slide I talk about the comprehensiveness of log collection. Yeah, so that would be included. Like you would collect that as well. So I don't believe they are now. It was really focused on Hadoop. Okay. Is that in your case?
Yeah, and if it is HTTPS or any Hadoop level, then Ranger audit is going to do everything.
Then Ranger, right.
Ranger audit, Hive or Yarn or HBase, like that.
Right.
So, but the question is we are saying log retention period is minimum 6 years.
For HIPAA.
But even HIPAA, we are using HIPAA, but auditing the retention period, even 1 month where it is eating the disk space, even 1 month logs. So how we retain the 6 years logs?
Oh.
Yeah.
So the question on the table is interesting because the question is really how do you retain logs for 6 years when, so maybe I didn't emphasize this enough. We're only collecting, if you notice the source, right, the source equals to is only audit logs. So the only audit logs are not as huge as, say, operational logs, right? So logs fall under multiple types. The audit logs typically are access, right, because it's access into the cluster and authorization. So they're quite a bit, but they're not as big as operational data. For example, if something went down or availability issues, that's captured in a different log. There are other logs I didn't even begin to mention because there's tons of var logs in there. These are very strictly tailored. They're just honed in on the audit logs. In fact, every log I give you an example of is actually, and this is not us calling it -audit, it's what the Hadoop ecosystem calls it that. So we don't have a choice. I don't think anybody has a choice, at least not in the HIPAA world. If you're using HIPAA, you have to have a minimum of 6 years. So Johns Hopkins does due diligence, and they don't care how much it costs, but they store it for 6 years, just at least the audit logs, all the access, so user is very big, user and the authorizing applications like Ranger. So yeah, so it's not a choice, we have to.
Yeah, authentication logs is okay, but authorization logs are the huge amount of the data.
It is actually, I did notice, it is a lot. It is a ton of data, but like I said, we have no choice. We want to capture that for due diligence so that any time that question is asked, we have an answer for that, you know. I think honestly, with this is not a talk about Docker, that's worse. That's very chirpy. You get tons of output to Docker, which we're trying to solve. But again, that's a subject for a different discussion. But at least here we know where to train the viewing on. So we get visibility to those particular you know, logs that we make available on the NFS mount points. But I agree, there are a lot of logs. We may compress it. You know, again, HIPAA doesn't tell you how to keep the logs. So you could, in fact, heavily compress it or glacier them out. So that's what I mean, I call it glacier. You know, Hopkins uses Azure, so they'll use the equivalent of that to basically lifecycle them out into cold storage, right? So you can put them in cold storage and pay 1/10 the cost. So, but again, it's not an option. Great questions, by the way. I do appreciate the questions. And I think I provided my email. So since a lot of what I shared, including those regex, I've not found anywhere. If y'all have additional suggestions or better suggestions, I'm always open, you know, to this, because as far as I'm concerned, there's not a whole lot of folks like us doing this type of work, because the devil is in the details. I've argued, and it's working well for us now, and that's why I thought I'd share that with the rest of you folks. You can actually literally take this and, you know, have your security people, if you're not the right personnel to do this type of work, because it is very detailed and very. I'm trying to look for the right word. It's not cumbersome, but it does take work. It does take work. Yes, sir.
So I have a question. So can you tell me a bit about your encryption strategy and your encryption in motion strategy?
Yes, so that's a great question. The question is about our encryption strategy for data in motion. So ePHI, which is our primary data in motion, is SSL encrypted. So we use SSL encryption, no questions asked, even inside the cluster. So not only from the ePHI pattern, that's external, going to the Hadoop, going to the HTTP cluster, that's all SSL. Intra is also SSL, and right now, the encryption for data at rest are Azure VMs. Every volume is encrypted. So it is at the volume level. So so if you're asking, are we using encryption zones? The answer is today no. We're not using encryption zones. If that was a question, Phil, sorry. I don't know if that was one of your leading questions, but it is encrypted at the volume level. Yeah.
Do you need to add an extra encryption zone in Hadoop, even though if your disk level encryption is enabled?
No, we don't have to. It's considered best practice. And if we have a use case, because remember, there's only one tenant right now. It's just the precision medicine team. But if you had multiple tenancies, I would argue that you should have encryption zones. What I do not mention is at APL, I also help manage a Cloudera cluster. I mean, that's one of our big clusters is Cloudera. And there we do use encryption zones. So absolutely, because we have multiple tenants. We got multiple sponsors, you know. We have, you know, one department that requires, you know, sensitive data, CUI data, you know, classified but controlled unclassified information. Back in the day, we called it FOUO, for official use only. That's in an own encryption zone. So great questions. Not in this medical project, not in this initiative, but in other initiatives on our Cloudera cluster, we absolutely use things like encryption zones. You know, it's a very good practice. But that's like security. That's less about monitoring and logging, and more about controls, back to controls. So, great question.
So,
Yeah.
you guys have a use case for de-identifying the data?
De-identifying what data?
Like any patient data or anything like
Yes.
how you guys are doing it?
I can't talk about that a whole lot because I'm not primarily involved with that part of it, with the data, with how the data is de-identified. But it's a pretty complex process because, as you know, depending on which doctor you visit and how information is captured and each one's identification system, there is a very complex sort of, you know, universal sort of identification in place. It's above and beyond all the various identity, sources, right? Every single source has its own identity for identifier for a patient. But at the end of the day, this platform in the middle, once it curates the data, has its own identification. And that then links it to those various other identities. So it's really a hierarchy, from my understanding of that, right? Because that's more on the, on the medical data, side of it. As the information security person behind all of this, or sitting on top, I should say, right? So we're a bit orthogonal, right? We impose controls and we collect all the security events. But we don't tell people how to do their, data architecting. So it's a good question, but yeah, and there is a method. Okay, I think that's a wrap. Well, thank you everybody again for your time, and enjoy the rest of the, the session. Take care.